Thank you, President Rudolph, Vice President Yanqing, President Jerry, and our audience joining us in person and online from around the world. I'm Michael Song, the Chairman and CEO of SuperMap. Now, today, I will introduce GIS root technologies that we have innovated and how they laid the foundations for Geo-intelligence application. Nowadays, geographic information technologies have been applied in many fields. Among them, digital government is one of the most important applications. As our digital society, digital defense, and industries digitalization. To support this application, we need Geo-intelligence. Several years ago, SuperMap provided the concept of Geo-intelligence pyramid. It has 4 levels: geo-visualization, geodesition, geodesign, and geo-control. From top to bottom, the technologies become more mature. To support Geo-intelligence, GIS platform software plays an important role. Several years ago, we published 5 technology architectures that compose of big data, GIS, AI GIS, 3D GIS, distributed GIS, and cross-platform GIS, simply as BitDC. Therefore, we said that GIS platform software is the root technologies of Geo-intelligence. The latest version we launched also brings a lot of upgrades, including multi-source video spatialization based on Big Data GIS and AI GIS, 4 new features of 3D GIS, Cloud Native GIS 2.0 of Distributed GIS, open source spatial database Yukon, and others. And I'm going to elaborate upgrades in these aspects. My colleague will detail the other features. Several days ago, we released the SuperMap GIS 11i. In this version, we used many brand new technologies. One of them is Yukon. Yukon is an open source spatial database that SuperMap developed in partnership with Huawei. The word Yukon comes from the title of an ancient Chinese geography masterpiece. Why do we need the spatial database Yukon? What is the best benefit of developing it? Let's figure out these questions from database ecology. PostgreSQL is the so-called world's most advanced open source relational database. As a spatial database extender for PostgreSQL, PostGIS is open source as well. At present, it doesn't support for 3D models yet. Practically, we need to do a lot of extensions, which is very inconvenient. The other open source database is OpenGIS. It's highly ranked in China. It becomes the top 1 in May this year. It is mainly developed by Huawei and customized based on PostgreSQL, but it lacks of authoritative extensions of open source database. For such reasons, we learned for an open source spatial database, which is much stronger than PostGIS. In the meanwhile, supports 2D and 3D integration. What are the advantages of Yukon? Since Yukon is maintained by SuperMap, we can upgrade spatial data models quickly according to the development of GIS technologies. It can analyze spatial data on the backend, greatly improving the spatial analysis performance. Besides, Yukon is open source, and data formats are open. Therefore, other GIS and surveying software manufacturers can use it directly. The technical architecture of Yukon can be divided into several layers. Features with the level new listed in this architecture are extended from PostGIS, and more capabilities will be provided next version. The yellow 2D polygon data used in this video was stored in Yukon. Both SuperMap iDesktop X and QGIS can access it. In this video, we stretch our 2D building polygon dataset saved in Yukon to our 3D dataset with a field that records heights of buildings, and then open the result dataset with SuperMap iDesktop X and QGIS. In addition to the capability we introduced before, Yukon supports for 3D models like BIM data. You can manage your BIM data with Yukon, browse and analyze data with SuperMap and other GIS software. You can get Yukon from those websites. Apart from Yukon, SuperMap also provides other open source products. You can find them from the GitHub website. The second technology is Cloud Native GIS 2.0. We launched the technology of Cloud Native GIS 1.0 in 2018, including microservice, containerization, and automatic orchestration. In the era of 2.0, we introduced Service Mesh and Serverless Computing. Service Mesh provides 4 abilities. The first one is service metrics. Service metrics can count and make the statistic of service communication. Service trees can detect exceptions thrown during the running of services, and then administrators can process them immediately. Access control refers to setting the access permissions between services to ensure that a service can only be accessed by authorized services. The last one is GREE release. So what's GREE release? The old procedure of upgrading an application system was like this. First, we developed an application system and allowed users to use it. After we updated, all users were required to upgrade. But some users may not want the upgrades. In this situation, we can adopt the GREE release technology. Users who want to try the new version could upgrade the application. The conservative users can switch to the new version step by step. This technology makes application release more smoothly. Another new technology is serverless computing. We disassembled the computing modules of microservices into function-level granularity, and then you could execute, extend, and pay for functions on demand. During the whole computing procedure, you don't need to manage any infrastructure like servers. The spatial microservice technology evolved 4 times. Before 2018, the whole WebGIS was a monomer service. In 2018, we broke it down into many microservices, each of which could run on a separate container. In 2020, we split each common GIS microservices into smaller microservices. Last year, we split each analysis microservice into 5 analysis services. And this year, we broke each spatial analysis microservice into functions. Every function can run independently. This is a real-time topology diagram of background services provided in SuperMap and Manager product. The nodes on the left and in the middle are workloads that continue to reside, such as microservices, and on the right are various spatial analysis functions. Once a request comes, related function instances will be coded. After the code start is completed, the spatial analysis will be performed immediately. As soon as the task completes, these replications will be destroyed and the resources will be released quickly. This is our compilation test. We found that the size of container image file was reduced by about 60%. The speed of starting a container was increased by 144%. Overall, we found that performing spatial analysis with serverless is much faster and save more resources. Here are the advantages of Cloud Native GIS 2.0. Service Mesh makes service management smarter. Serverless computing makes data processing faster and more flexible and helps save resources. The third section is about 3D upgrades. The latest version of SuperMap GIS provides a series of 3D highlighted technologies. I will introduce the 4 key technologies. The first of all is S3M 3.0 upgrades. The second is Hi-Fi 3D SDK with enhanced performance and effects. The third is Hi-Fi 3D Sim Browser. The last one is Web 3D SDK, which is brand new. The first highlighted technology is S3M 3.0, that both the performance and effects are enhanced. Compared to S3M 2.0, S3M 3.0 updates these capabilities. First, It supports data compression, greatly reducing data size and improving the data access speed. And then it supports OBB bounding boxes, making the scheduling of spatial data more accurate, thereby improving the performance. And next, it supports skinning and skeletal animations, make animations on scene more diverse. It also supports PBR materials and mask textures, making visualization effects more cooler. The last, mesh models can save multi-dimensional vertex properties. We tested the performance of S3M 3.0. The results show that data size can be reduced by 30%. Memory usage can be reduced by 40%. And loading performance is almost twice that of S3M 2.0. The second highlighted technology is Hi-Fi 3D SDK. Not both the performance and effects are enhanced as well. We provided 3D GIS plugins for game engines like UE4 and Unity before, and then they could access spatial data and perform spatial analysis. This year, we provided a plugin for UE5. We call them SuperMap Hi-Fi 3D SDK. There are more spatial effects in the new SDK, like the change of light, the effect of sunset, the simulation of raining and snowing, the spatial effects improving obviously. Additionally, we provide some post-processing effects such as screen space reflections. From the video, we can see the sky and building reflected in the glass of the building on the left. We provide powerful abilities to beautify the scene, like the stretched building blocks. It is generated based on 2D vector data, hence it's a little plane. To beautify it, the old way wants to attach textures on the model, but the result is not satisfying. So how to make it more realistic and make the whole scene more shocking? Now, we can distinguish the types of materials according to floor intervals and map them. Compared with the stretched building blocks, the granularity of BIM is finer and refined to components such as pipes, doors, and windows. BIM is highly accurate, parametric, and has detailed semantic information. Its physical types are so clear. Therefore, we think their materials expressing physical types like metal, glass, stone, and the like. And then we replace the materials in batches for each type of component according to its physical type, beautifying the scene. The fine model does not have as fine-grained object representation as BIM. A single building may be an object. There are not too many details on mesh and no semantics. The details are mainly expressed through texture. So what should we do to distinguish the windows, walls, and doors on the side of the building? We could give semantics to objects with the technology of mask texture, so as to beautify the scene at the detail level. SuperMap Hi-Fi 3D SDK also supports physics engines, such as a flowing water particle system. It takes gravity into account and is very close to the real scene. An engineer of UE China developed this demo that combined UE and SuperMap Hi-Fi 3D SDK. It simulated an airplane that took off in a low visibility snowy day. After flying to the certain height, we can see the situation above the clouds, and a big city appears on the scene. UE5 provides a coordinate system for larger scenes, and after we support UE5, large sceneries like our big city can show on our scene, achieving the macro integration. The third highlighted feature is a Hi-Fi 3D Scene Browser. It's our new product. The product name is iExplorer 3D. It is a desktop product for browsing 3D scene data. It is developed based on UE5 plus SuperMap Hi-Fi 3D SDK, and it's for free. It has 3 features. The first feature is it supports massive multi-source data. The second is it supports hi-fi rendering effects. The last feature is it supports cloud rendering and allows to publish to the website. All these screenshots are from iExplorer 3D. We can find that iExplorer 3D supports various data. The fourth highlighted feature is the brand new Web 3D SDK. The open source product Season released Season GIS earlier. Although it supports the developer ecosystem, its capabilities are not that powerful for some heavyweight applications. Based on this framework, SuperMap wrote a lot of codes and generated a product named iClient 3D for Season. The product supports low-code development, various data formats, and abundant data types. And recently, we released iClient 3D for WebGL. It's a self-innovated architecture WebGL engine. It supports 2 low-code development frameworks and more realistic rendering effect. Besides, it provides more abilities and supports more data types. This is a rendering effect on the website. It supports irradiance map of diffuse reflection and specular reflection. You can see the sky reflected on the glass and the lighting effects. We can simulate the snowy day on the website, including the effect of snowflakes and snow on the ground. This is a demo of screen space reflection on the website. The street after the rain affects the building on the ground. We can export PBR materials of stretched building blocks from UG and load them on the WebGL engine. The representation of scene is much more beautiful. Now, let's review the technologies I shared today. Brand new open source spatial database Yukon, Cloud Native GIS 2.0, and 4 features of 3D GIS. The motto of SuperMap R&D Institute is, have the courage to do what nobody does. We have done many world-leading researches for developers and provided cutting-edge technologies like Cloud Native GIS 2.0, helping users create more GIS values. And we will keep cultivating in advanced technologies. That's all for my presentation today. Thank you all for your time. Thank you.